Welcome, YF 2024. Let's take this question. It says, which of the following terms has different dimension from the other? So they are asking us to find the dimension, the unit dimension or dimensional formula for each of these terms or physical quantities, combined physical quantities, and then see the one that is different from the other. So there is a negative equation, which means out of these four, three will have the same dimensional unit, and then the one that doesn't have the same will be the answer. So let's start. Let's start with the first one: stress times strain. Stress times what? Strain. Now, the mathematical definition for stress is force, the unit what? Area. I know that you know that pressure mathematical definition is what? Force per unit what? Area. But still, both of them have a difference. There is a difference between pressure and stress. When you're talking about pressure, you are talking about force applied per unit area on a surface. That's if you have a surface, this is the surface. How much force is being applied on that area? Then that's pressure that you call it. Then for stress, stress happens within the body of a material. So if you have a body that like this, within the internal molecules of this material, what kind of pressure is it giving out on this material? You understand? When subjected to certain things like heat or being beaten or being stressed, like in elasticity. So when you draw a material, try to stretch out a material, the pressure you're attaching there is actually called a stress, because you are stressing that thing. It's just like saying that someone is stressing you out. Understand? That means the person is drawing out a lot of strength from you, energy from you. So stress happens within, while pressure happens externally, while stress happens internally. Okay, so let's go back. So stress is force per unit area times strain, and then this one is strain. The mathematical definition of strain is extension over length. That's extension per unit length. So let's find the dimension for this combination. Dimension will be, we define force. Force is mass times acceleration. Area is length times length. So the dimension of area is L raised power of 2. And then here, extension is a length on its own. Original length is also a length, so they will cancel out. What is left is what? Mass times acceleration over L squared, which is what? Stress. That's F over A. So mass, dimensional unit for mass is capital letter M. Acceleration, which is velocity over time, which has the dimension of L over T squared. Acceleration here will be L T raised power minus 2. That's if you take T raised power 2 to the top, it becomes raised power minus 2. So that's acceleration, then over this L squared here. So this one L will cancel one of the L's here. Here is L times L. So one L will cancel. So one L is left here. So what is now left is M L raised power minus 1. This one that is left, if you take it to the top, it becomes minus 1. And then T raised power minus 2. So this is the dimensional unit for this first combination, which is stress times strain. And funny enough, this dimensional unit is also represent for pressure, because when you say pressure is also defined as what? Force over area. That of strain cancelled out here. So the actual dimension that we found is also the same as that of pressure. So pressure has the same dimensional unit as stress. So now A and C are the same. So let's look at B. B says stress divided by strength. Now stress is what? Force over area, then divided by strength, which is extension over original length. Now, if you do your mathematics, division of fraction, this is F over A times L, that's original length over extension. So this one, the dimensional unit for original length is L, and the dimensional unit for extension is still L. So they will cancel out. So you are still left with what? Force over area, which is the definition of stress or pressure. So it will still have the same dimensional unit there. ML minus 1, T minus 1. So A, B, and C have the same dimensional unit. So without even bothering further, I would say that torque D is the answer. Which of the following term has different dimension from the other? So D will be the answer. D will have a different dimension. But however, let me just find the dimensional unit for torque. Find the dimensional formula for torque. So if you define torque, torque is defined as the product of force times perpendicular distance. Force times perpendicular what? Distance. Which is what? F times L. So force, which is mass times acceleration, acceleration is length times that minus 2, then times this perpendicular length here, which is L, will be equals to ml squared t minus 2. You see that this one here is different from this one here. So torque is the one that doesn't have the same dimension as that. And torque has the same unit as what? Work done. And also have the same unit as what? Moment. So torque is defined as the moment of a couple. So there is a tutorial on that where we'll be doing equilibrium of forces. Then we look at moment. So the answer to this question is D. Thank you.